Hello there, it's exercise 19F for year 12 maths students. I'm looking at kinematics. Now kinematics can be SUVAT. There's constant acceleration equations like v equals u plus at and s equals ut plus half at squared, all those kind of stuff. And it could be like we've got here, we've got a graph of showing what seems to be constant deceleration. And it could also be those questions where you get variable acceleration. And you get an equation for either the displacement, the velocity, or the acceleration. We know we can use calculus, differentiation, and integration to move between the three types of things we want. So could be, now, what we're doing here then is a range of different questions, so I honestly don't know what's coming. Other than spotting there were three questions on this, so we'll have a look at three questions. A boat moves in a straight line. At t equals 0, it passes a rock, and it moving with velocity of 4 is acceleration. Now look, this is what I meant. So this is an equation, it is an equation for the acceleration. A equals 12 minus 6t. And it says, find the time when the boat changes direction. Now, you know when the boat changes direction, when its velocity goes from being positive and then switches to being negative. Because that tells you it's going the other way. So velocity is the key here. So I know that a equals 12 minus 6t, and I also know to get the velocity I integrate the acceleration with respect to t. So what do I get when I do that? I get 12t minus 6t squared over 2. Well, I reckon that's 3t squared. Don't forget your constant of integration. Now this is where we get told some stuff. It's t equals 0, its velocity is 0. So t equals 0, not 0, velocity is 4. V equals 4. So therefore 4, the velocity, is equal to, oh right, that's 12 times 0, so is equal to c, because all of that disappears. So therefore my velocity is 12t minus 3t squared plus 4. Which is great. Now, what's it want me to do? Oh, yeah, that's right. Find the time when the boat changes direction. So I need to know when this is negative and positive. So we set this equal to 0. That's the point at which it changes from one to the other. And we solve this equation. So we might as well. Now, just remember, this is really minus 3t squared plus 12t plus 4 equals 0. And I'm just going to put that into my quadratic equation solver. So it's a polynomial equation of degree 2, and I've got negative 3 for a, I've got 12, and I've got 4. Here, the first answer is not very nice, so I get an answer which is t equals 4.31. I must admit, I was expecting a nicer answer than that, and the other answer is a negative, so I'm assuming they only want the positive answer. So I've got 4.31 seconds is when the boat changes direction. B. Find the maximum velocity. Well, maximum velocity occurs, well, I suppose, when, you just need to be a bit careful. It's between 0 and 8 seconds. What does the graph look like? The velocity graph is this rather unfriendly upside down. We know it's at 0. So if I just drew the velocity graph, we have 4.31. We've got a 0. We've got 1 as well. I think it said, yeah, it was minus 0.31. So my graph is an upside down version of a quadratic, and it looks like that. And so what I was just a bit concerned was 0 to 8 were the end points where it was at its maximum. But I don't actually think it is. I think there's a point around there somewhere between nothing and 4.31 when we will get maximum velocity. And you get this when the acceleration is 0. Which is quite nice actually, because we've already got the acceleration. Normally you have a velocity equation and you have to differentiate it. But if we do that, we just get back to this. So when a is 0, or I suppose I could have written when dv by dt equals 0. But we don't need to differentiate in this case. As I say, we've already got the acceleration. So I'm going to say 12 minus 6t equals 0. It's the easiest equation in the world to solve. T, I reckon, is 2. Well, just notice actually, it does say find the maximum velocity of the boat. So that I've only found the time when this takes place. So max velocity, the v equals, what was my equation? It was this, wasn't it? So it's 12t minus 3t squared plus 4. So when t equals 2, it's 12 times 2 minus 3 times 2 squared plus 4. So what's that? 24, 28. Is it 16? 28 minus 12 is 16. Yes, that's right. Done it. 16 meters per second. Nearly got into a bit of a muddle there, but got there in the end. So hopefully they're right. And my last question says, at what time does the boat pass the rock again? All right, I'll do that on the next slide. So this is part C. So passes the rock again when x is 0. So we assume the rock is at 0, and when it gets back there, it's at 0 again. So what was my equation? It was there. Oh, I should point out, yeah, so in order to get x equal to 0, I need to find x, and you find x by integrating v. And what was that again? It was the integral of, let's find it, is 12t minus 3t squared plus 4 dt. So I need to integrate this. What do I get? I get 12t squared over 2, that's 6t squared. 3t cubed over 3, that's just t cubed plus 4t. Plus a constant, of course. Different constant this time. And, well, we know that t equals 0 when x equals 0. So, presumably, that gives me a value for c to be 0. So, x, if I put 0 into there, will give me just 6c t squared minus t cubed plus 4t. I'm just going to write in brackets c equals 0. So this is my equation for x. And as I said, I think I've got to solve it. I've got to set it equal to 0. So therefore, 6t squared minus t cubed plus 4t equals 0. And the easiest way to do that is a cube it. I could chuck it into my calculator. But I'm going to do t there as a common factor, 6t minus t squared plus 4. Is that the same equation as we had before? 6t. No, it's not. It's slightly different, isn't it? So I'll just put that into my quadratic equation formula. I'm going to put a is minus 1, it's minus t squared. B is 6, and c is 4. And this gives me, well, it gives me t equals 0 for, obviously, for the first one. And then I've got t equals 6.61, and then, oh, that looks negative, minus 0.6. So this is when it happens again, so I'm not going to bother with the negative. So I think it said time. Find what time it happens. Yeah, so I'm going to say 6.61 seconds. What have I got? 4.31 I got, 16 I got, and now 6. Yeah, so we're good. Example 2. A car accelerates from its parking space and moves in a straight line. Its velocity at time t seconds satisfies this scenario. Now we'd call well, these are slightly different, aren't they? You'll notice we got two parts to it. Between 0 and 2 it follows this equation, and after 2 seconds it follows this equation. And usually these two equal the same speeds, the same values at the crossover at 2. So if you put 2 into there and then put 2 into here, I suspect it's the same answer. Find the displacement when t equals 2. Well, let's just this is the one where you use when t is equal to 2. So I'm going to say x is the integral of that. We integrated a lot on the last question. I'll do it again here. So because it's when t equals 2, I'm going to integrate this one, dt. And what does that give me? It gives me 14t squared over 2, 7t squared. 5t cubed over 3. Now that doesn't simplify very nicely. But don't forget your constant. Moves in a straight line. Well, we know certain information, I suppose, do we? Find the displacement of the car from the parking space. So basically it means x equals 0 when t equals 0. So that's interesting the way that's worded, isn't it? From the car parking space. So x equals 0, t equals 0, so therefore c equals 0. And by definition, therefore, when I put t equal 2 in here, x equals 7 times 2 squared minus 5/3 of 2 cubed. And what do I get for that? So 7 times 2 squared minus 5/3 times 2 cubed. I get 14.7 equals 14.7. So now it says we'll do the same thing when t equals 5, but obviously when t equals 5 we have to use this one here because it's greater than now than 2. So we just got to be a bit careful that you use the right formula. So I'm going to do that over here. X is the integral. Now, by the way, I could have done the first one because it was between 0 and 2. I could have done like that. So for that reason, because it's between 2 meters and 5 meters, I'm going to do that. Between 2 and 5 to work out its displacement. And it's of 13 minus 20 t to the minus 2 dt. And it'll be easy if I do it as a definite integral like this. So this will become 13t. Now add a power, it's actually minus 1, 20 t to the minus 1 over minus 1. And I don't have to worry about constant now because I've dealt with the constant in the 2 and 5. So what have I got? 13t plus 20 over t. Between 2 and 5, chuck the 5 in, 65 plus 20 over 5 is 4. And then I take away the same thing with 2 in, 26 plus, well, 20 over 2 is 10. So it's 69 minus 36. Sounds to me like 33 meters. But there's a warning here. This is how far the position of the car has changed between 2 and 5. But it was already 14.7 meters away. And it just went a further 33 meters away. So I think here I'm going to write x equals the 33 meters plus the original 14.7 meters, which is 47.7 meters. And it would be easy to go wrong there and forget the original distance that you are away. Now then it says, at what time is the car 35 meters from the parking space? There's a couple of things here. I'm not really sure if it ever gets there within the first 2 seconds. So because of that, I'm going to use this equation. So I'm going to set 7t squared minus 5/3 t cubed equal to 35, just to see if that ever gets there. And I suppose I'd better rearrange it. 5/3 t cubed minus 7t squared. So I'm moving everything over to there. Plus 35 equals 0. And if I type those in, I get this solution. Oh, right. So I had it ready on my calculator. It's minus 1.86 is the only solution it gives you. So basically, this doesn't give you 35 meters. So therefore, we have to instead, we have to remember it goes 14.7 meters initially, plus some x that we want to do, and we want to equal 35 meters. So the total distance is 35 meters, and 35 off that is at 20.3 meters. Now of course I've done a lot of this up there, haven't I? So I can write 13t plus 20 over t. That's what I've got up here. Not from 2 to 5 now. I'm going to say to 2 to t, and I want that to equal 20.3, and it's this t that I'm going to find. So I substitute the t in, 13t plus 20 over t, that looks the same. And it's that t that I'm going to try and find, minus, if I put 2 into this, I get 26 plus 10 equals 20.3. So said a different way, we've got 13t plus 20 over t equals, that's 36, that's 56.3, times everything by t minus 56.3 t plus 20 equals 0. And I'm going to solve this. I'll just do it on the calculator quickly. I'll just type in, there's actually 2 answers. One of them says 0.39. The other one says 3.94. And of course, this one's not in the right range. It has to be bigger than 2. So I think this is the answer. And I've run out of time. So I think there were answers. Yeah, 3.94. There's one more question, which we'll do in class. And then there's exercise 19F. So we've got 2 out of 3 done. It shows you how long they are. All the best.